Okay, everyone, we're recording now. So number one, if I asked you to write the expression for 6 less than 11, how would I write it? 11 minus 6. This is 6 less than 11. So that one is A. The product of 12 and 6.
Multiplication.
Yep, product means multiplication, so it would be 12 times 6. A number increased by 16. S plus 16, because we've increased by 16. Good. All right, evaluate each expression. This is order of operations. What comes first, multiplication or addition?
Multiplication.
Multiplication. So it's 15 times 3?
45.
45 plus 7? 52. Yep.
I didn't even know we had side answers until I did that problem.
All right, 2 ways to do this. We could distribute, or we could follow the order of operations. Since we can simplify the parentheses, what do the parentheses simplify to? 9 minus 3. 6. And then what do I do with the 5? Multiply it by 5. Okay, so 5 times 6? 30. Okay, I could also distribute the 5. What's 5 times 9?
45.
And what's 5 times 3?
15.
And what's 45 minus 15?
30.
See how that works?
I thought that was only.
You can do it both ways. Okay, next problem. What's going to come first in order of operations? Parentheses. So what is 4 plus 3? 7. So now I have 8 times 7 minus 21 divided by 7. Now what? 8 times 7, okay. 56 minus 21 divided by 7. Yes, division would come before multiplication, or before subtraction. Yep. So 21 divided by 7 is 3. 56 minus 3, 53.
Yeah, I know. I got so excited. I freaked my mom out. I wasn't in the store.
All right. Do you guys not need a review? Because we could just take the test today. I don't need the review because I don't need to I know how to do all of this. Okay. So when I'm talking up here, it's really discourteous to sit and talk about something that's not even related to math. All right. If I have A times B plus 6, what do I do when I'm given A and B? I substitute those in first. Okay, so I'm going to substitute 3 in for A, and I'm going to substitute 7 in for B, and then I'm going to add 6. Now I'm going to follow the order of operations. What's first, multiplication or addition? Okay, 7 times 3?
21.
Plus 6? Good. This was A. Same thing here. I'm given R and S. R plus 3S minus 7. So I'm just going to substitute in and rewrite it. So I have 9 plus 3 times S is 4 minus 7. What comes first, addition or subtraction?
Just either right.
Good. Both of them have the same order. So when they both have the same order, we just go left to right, and whichever comes first, left to right. Okay? So, but first, you're right, multiplication comes first. So I have 9 plus 12 minus 7. 9 plus 12, 21. 21 minus 7, 14. Again, substitution. So if U is 4, V is 6, and W is 9. Multiplication first. And then what? Yep. 4 plus 30. And what's 34 minus 9? 25. Okay, properties. So do we need a review of these?
Yes.
Okay. This is an example of the identity property. This is actually the identity property of multiplication, because do you see the multiplication symbol?
Yes.
Okay, so the identity property, whether it's multiplication or addition, is multiplying or adding a number to the original number and getting the original number in the end. So if you think about identity, I'm maintaining my identity before and after. Maybe a way to remember it. Okay, so if I'm A, in order to maintain my identity after, I would multiply by 1 because that doesn't change my identity. Does that make sense? So A times 1 is A. So what would I have to add to A to maintain its identity? Yes. So this is the identity property of addition. So multiplication, you multiply by 1. Okay, with the addition property of the identity property of addition, I'm going to add 0 because both of those maintain the identity before and after. Okay. How about the inverse property of multiplication? The inverse property of multiplication is what number do I need to multiply by A to get 1?
Itself?
So,
No, A times A is A squared.
So it'd just be 1.
A times 1 is A. What number times A will give me 1? Think about the property I introduced. I called it the negative. A times negative A is negative A squared.
Negative 1 then.
Negative 1 is negative A.
fourth.
A fourth? If I multiply A times 1/4, it's 1/4 A.
Oh, yeah.
It's all right. I called it, and when I started it, I called it the inverse property. What does inverse mean?
It's negative. It's the
Reciprocal. What's the reciprocal of A?
A over 1 over A.
1 over A. Right? So if I multiply A by its inverse, or reciprocal, those are synonymous, inverse and reciprocal. If I multiply A by its inverse or by its reciprocal, I get 1. Which is why when we undo multiplication, we multiply by the reciprocal, because a number times its reciprocal is always 1, and that's how we get rid of that number on the left side when we're moving it to the right. Yes?
So when you're doing, like you said, inverse reciprocal.
Multiplicative inverse does. Multiplicative inverse. So this is the inverse property of multiplication. The inverse property of addition is what number do I need to add to A to get 1, or to get 0 actually, sorry. This is the inverse property of addition. What's that? No, we're addition.
Oh, addition.
What number do I, what's that?
Subtract.
Yep, so I'm adding
Negative.
negative A. Okay, so of addition, the inverse property, so the inverse property is really how you undo multiplication or how you undo addition. Okay, if I had negative 7 and I needed to undo that, what do I add to it?
7.
Yeah, so the inverse of negative 7 is positive 7 with it when I'm adding. The inverse of negative 7 when I'm multiplying is what?
Divided by negative 1 over 7.
Okay, which is also multiplying by
1 over 7.
negative 1 over 7. Yep, don't forget the negative. The inverse of negative 7 multiplying is the reciprocal, which is negative 1 over 7. Okay, so these are called identity properties. This is identity property of multiplication and addition. These are the inverse properties. This is the inverse of multiplication, the inverse of addition. Okay? You guys have a strategy to keep those straight in your head for tomorrow?
Yes.
You'll need to know these.
So the inverse of addition
Is the opposite sign. Same number, opposite sign. Inverse of multiplication is the reciprocal. Okay, let's talk about the associative property. Okay, the associative property. The order of the numbers doesn't change, but what does change is which numbers are associated together. Do you see how the parentheses in the first are around the 3 and the 2 and the 1? And in the second are around the 3 and the 2. It's still in order 3, 2, 1 in both examples. So the order of the numbers didn't change, but what did change was the association. So the associative property many times will have a parenthesis around it. Okay? But just because you see a parenthesis doesn't mean it's association. It could be distributive property. Okay? So when I'm looking at this problem, I would do parentheses first, right? 2 plus 1 is 3 plus 3, 6. Here, 3 plus 2 is 5 plus 1, 6. So the associative property of addition and multiplication basically says it doesn't matter which numbers you add or subtract or multiply or divide first, you're going to get the same answer. Okay? Associative property of multiplication would look something like this. 3 times 2 times 1, 3 times 2 times 1. So 3 times 2 is 6, times 1 is 6. 2 times 1 is 2, times 3 is also 6. Okay? The associative property says it doesn't matter what you associate first, you'll get the same answer. Okay? The commutative property, the order doesn't matter. That's what I want you to think of when you think of commutative. The order doesn't matter. So if I had 3 plus 2 plus 1, or 2 plus 3 plus 1, I can change the order of the numbers, and when I add them all up together, I'll get the same number. Okay? With commutative property of multiplication, I can change the order of what I multiply. 3 times 2 times 1, or 2 times 3 times 1. Get the same answer. Do you see how I'm not associating anything? So it's not the associative property. What I'm doing is I'm changing the order. Okay? What about, I'm going to give you a trick one here. Let's do times. No, let's do this. Which property is this? Who thinks it's associative? Raise your hand. Who thinks it's commutative? Raise your hand. Who doesn't know? Raise your hand. Okay. So think about associative property and what I told you. With the associative property, you change the association. In the first example, the association was 3 and 2, right?
Yes.
In the second example, did the association change? It didn't. I still have 3 and 2. Okay? So what did change? Well, the order of the numbers did. First I had 3 plus 2 times 7, and then I switched it to 7 times 3 plus 2. This is an example of the commutative property of multiplication. Because I'm multiplying this number times 7, and I'm multiplying 7 times this number. Another way to write this, 5 times 7, 7 times 5. You see how I just switched those numbers up, but I'm still multiplying. So this is a commutative property of multiplication. Okay? What else am I missing? Distributive property. That's an example of the distributive property. This is equal to 3x plus 21, because I'm going to distribute the 3 to both terms. That's the distributive property. Okay, so we have the identity, multiplication and addition. We have the inverse, multiplication and division. We have the associative property, and we can really make that multiplication and division. The commutative property, multiplication and division, and then the distributive property. Okay, you need to know all of those because there will be a question or two on the test tomorrow. Okay. So let's look at these properties now and see if we can figure out, based on what we just went through, which property fits. 1 times 15 is 15. What'd you say, Alyssa? Identity, and it would be the identity property of multiplication if I asked that. But in this case, all you needed to know was identity. Because I started with 15, I ended up with 15. I maintained the identity of 15. identity property. How about this one?
Associated.
Associative, yep. These numbers were associated first, and then they switched to these. The order did not change. So that's the associative property. Make sense?
Yes.
All right, next, simplify 4 plus x plus 6. This one threw a couple of you for a loop who are working on it. What I want you to remember when you see a problem like this, what number is always in front of this parenthesis?
1.
Yeah, so I could, if I needed to, distribute. So I have 4 plus x plus 6. Normally, though, when you see this and there's no number in front, you can immediately just drop the parentheses. You don't need them anymore.
Okay.
Or if you need to see that, put a 1 in front and distribute the 1, and you'll see it's the same as dropping the parentheses. And after you do that, all you have to do is combine like terms. 4 and 6 are like. X doesn't have anything to combine with. So it's just x plus 10, which is letter A. This was associative. Okay?
That makes sense.
All right. This one, again, I really don't need the parentheses there because the 1 in front of it, if I distribute the 1, I can just drop them. So this is just 7 times b times 8. Well, 7 times b is 7b, and 7b times 8 is 56b.
Yes.
Okay, find each sum or difference. -5 plus 12. Let's review. While I've got the recording going, so if you need help still on positive and negative numbers, let's review a few rules that will help you. If the signs are the same, if they are both positive or they are both negative, add the two numbers up, and the sign of that sum will be the sign of the two numbers. As an example, we all know 2 plus 3 is 5, right? I add 2 and I add 3 and I make 5 the same sign as the 2 and the 3, which are both positive. Okay? If they're both negative, I still add the numbers up. And it makes sense because if I'm starting at 0 and I go 2 units left, I'm at -2, and then I go 3 more units left, right? I'm going further negative. I'm not going the other direction. So if I have -2 minus 3, I'm going to add the two numbers up, and I make that number sign the same as those two. Okay, same sign, think addition. Even though they're both negative, you always you think you associate negative with subtraction, but if they're both negative, you're getting further negative. So you're going to add them up and then make the number that's the sum the same sign. If they're both opposite signs, think subtraction. Okay, if they're opposite signs, think subtraction. And you can just subtract the smaller number from the bigger, forgetting the signs. And then you can decide what sign to give it. Okay? So when I look at this one, what's the smaller number? And the bigger? 3. What's 3 minus 2? 1. Which is bigger, the negative or the positive? The negative, right? Because the negative's with the 3. The positive's with the 2. So I know the difference in these is 1, and I know it has to be negative because the bigger number was negative. If I started at 2, positive, and I go 3 negative, 1, 2, I'm at 0. 3, I'm at -1. Okay? 3 minus 2, we know this is 1, but the reason it's +1 is because 3 is bigger. Okay, so when the signs are opposite, it will always be a subtraction problem. You can disregard the signs and just subtract the smaller number from the bigger, and then analyze which sign you need to give it based on the number that's bigger in the problem. The bigger number has a positive, your answer is positive. If the bigger number is a negative, your answer is negative. Does that make sense? All right. So this one, we have -5 plus 12. It's a subtraction problem. 12 minus 5 is what? 7. Is it +7 or -7? Positive, because 12 is the bigger number and it's positive. Okay, so it's 7. Don't do this to me, board. Okay, next one. We have negative 17 plus negative 12. Well, first off, how could I rewrite this without two signs right next to each other? What's this equal? Negative 17 minus 12.
Yes.
Right? And then plus 24. So let's focus on the negative 17 minus 12. They're the same sign. Am I going to add these or subtract them? Add them. If they're the same sign, you add. Okay, so I'm just going to add 17 and 12. Forget the sign right now. 17 and 12
Negative 39.
is 29. And because they're both negative, it's negative 29. Okay? Now I have negative 29, and my board is still not wanting to function. Negative 29. And then I have plus 24. So these signs are different. Is this an addition or subtraction? Subtraction. Forget the signs. Forget the signs. Just take 29 minus 24. 5. Now let's analyze what the sign needs to be. Which number is bigger? 29. What's the sign of 29? Negative. So the answer is negative 5. Make sense? Negative 5. Let's see if the board's decided to pick up, and it has. Okay, 14 minus 24. Addition or subtraction? Subtraction. Which one's bigger? 24. So 24 minus 14 is what? 10. And which one's bigger, the 24 or the 10 or the 14? 24. So is it positive or negative?
We know negative.
Negative 10, because 24 is negative. Does that make sense? 24 is negative. This is the same as positive 14 minus 24. Okay, or plus negative 24. So when I take the difference and get 10, it's got to be negative 10 because 24 is bigger. Both negative. Addition or subtraction? Addition. What's 16 plus 15? 31. What's the sign have to be? Negative. Negative 31. Making sense? Okay. Multiplication. What are the rules for multiplying a positive and a negative number? If I have a positive times a negative.
It would automatically be negative.
Negative. Two positive numbers multiplied together. What's the sign?
Positive.
Positive. Two negative numbers multiplied together. Positive. Okay, so the only time it's negative is when they're different signs. Okay? So we're going to work, we've got parentheses here. Negative 6 times negative 2 is positive 12. Positive 12 times 11 is positive 132. Okay, same rules for multiplication work for division. If they're opposite signs, your answer will be negative. Okay, so really what I need to do is just figure out 325 divided by 5. That's 6, which is 30, 65. But I know one's positive, one's negative, so it's got to be negative. Negative 65. Again, negative divided by a positive will be a negative. Negative 36 divided by 4 is 9, and I have to make it negative. So it's C. Okay, again, substitution here. If A is negative 3, B is 4, and C is 6. So 4 minus, come on, 4 minus 6 minus 3. So let's just start left to right. What's 4 minus 6? Subtraction or addition? Subtraction, and it's 2, and it's negative 2. Yep, so this is negative 2. Then I have negative 2 minus 3. It's addition now because we have two negatives.
Yeah,
So it's 5, and it'll be negative 5. Okay, let's put the numbers in again. A is negative 3, B is 4, C is negative 6. All of them are negative. So this is just an addition problem. My answer is going to be negative. 3 plus 4, 7. 7 plus 6, 13, and they're all negative, so it's negative 13. Adding and subtracting positive and negative numbers making a little more sense? Okay. B times C. B times C plus A. What's 4 times negative 6? Negative 24. And that's minus 3. So is this addition or subtraction? Addition. 24 plus 3 is 27, but it's got to be negative. Okay, simplify each expression. What's 7a times negative 3b? It's going to be negative. 7 times 3 is 21. A times b is just ab. So negative 21 ab. Negative 5x times negative 12y will be positive. 5 times 12 is 60. X times y is xy. How do I find the mean or the average of a set of numbers?
You add them all up and divide by how many integers there are.
Yep. 22 plus 15 is 37. 37 plus 31 is 68. 68 plus 40 is 108. 108 and 27 is 135.
Totally got some.
And divided by 5. 5 goes into 13 twice. Remainder 3. 35, 7. 27.
Oh, 27. Okay. I got that.
Which decimal is equivalent to 3/5? Mm-hmm. 0.6. One trick that I use for numbers that are factors of 10. So as an example, 1/5, 2/5. Think about the 5 on the bottom, the denominator, factors of 10. Let's make that 3 halves. Make it 5 halves. 2 and 5 are both factors of 10. Everybody agree? Okay. If I had a fraction like this, how do I make that a decimal? Yeah, or you just write it as you read it. How do I read this fraction? 2/10, 0.2. Right? Because tenths, that's the first decimal spot after the decimal. Okay? So if I could get any fraction with a denominator of 10, I could just see what it is right away. How do I get 5 to become a 10? Times by 2. So if I multiply top and bottom here by 2, I haven't changed the value of it because it's the same as multiplying by 1. The top becomes 6. The bottom becomes 10. How do I read that? 6/10, which is 0.6. Okay? So if you have any number in the denominator that can go into 10, make the denominator 10, multiply the numerator by whatever you needed to make the denominator 10, and you have your decimal really easily that way. Okay? And it's not repeating. It's just 0.6. Repeating forever, right? It's just 0.6 and it ends. Okay, how about this? How do I say this number?
125,000.
125 thousandths.
0.125.
It's just 125 thousandths. That's how I say it.
Yes.
I would either say 0.125 or 125 thousandths. The third place after the decimal is the thousandths place.
Correct.
Okay? So I would just write it as a fraction exactly as I say it. 125 thousandths. Now all I have to do is simplify. I can look at this and know that 25 is going to go into both evenly. 25 goes into 125 5 times. 25 goes into 100. How many times? To 100. 4. So all I have to do to get to from 100 to 1,000 is add a 0, right?
Yeah. 40.
40. Am I done simplifying?
No.
What's next?
Divide both by 5.
Yeah. If I divide both by 5, I get 1/8.
Dang, got that.
Okay, write 4 and 5/8 as a fraction, meaning an improper fraction because it's a mixed number now. So how do I convert a mixed number to a fraction?
You
Multiply the whole number by the denominator and add the
And then it's over the denominator, right?
correct.
So 32 plus 5 is 37/8, which is letter D. Okay, when I multiply fractions, first off, I've got a negative and a positive. It's a negative times a positive. A negative, so I know my answer is going to be negative. So I can already, or this isn't going to be it. It's one of these two. When I multiply fractions, we just multiply the numerator across, multiply the denominator across. So 2 times 7 is 14. 5 times 10 is 50. Can I simplify this?
Yes.
Okay, what's the value of the expression 2/3 times A times B if A is negative 6/7 and B is negative 3/10? 2/3 times negative 6/7 times negative 3/10. What's the sign of this answer going to be? Positive or negative?
Positive. No, negative. Negative because a negative times positive.
It's gonna be positive.
Oh, no, it is
A
positive.
negative times a negative is a positive times a positive is still positive.
Yes.
So the answer is going to be positive. Now all I have to do is just multiply the numerators across. 2 times 6 is 12. 12 times 3 is 36. 3 times 7 is 21. 21 times 10 is 210. Okay? And I know it's positive, but I need to simplify. I know 3 goes into both. So that's 12 over 70. Now I know 2 goes into both. 6 over 35. Okay? Another way that you can simplify this without having to multiply across, and this is what I normally do at this point. If I had just the fractions, 2/3 times 6/7 times 3/10, I'm always looking for things I can cancel out or reduce before I even start multiplying. The commutative property says the order doesn't matter, right? So I could write 2/3 and 3/10, or I could write 2/10 and 3/3. I can switch the denominators and get the same answer. So if I recognize that, what's 3 divided by 3? 1. So those go away, and that becomes 1. What's 2 divided by 10?
5.
So 1's on top, 5's on bottom, right? So now when I multiply across, I get 6 over 35, which is what I got the first time. It's a lot faster because then you're not having to get such big numbers you're having to reduce. You can just go ahead and cancel terms early, multiply across, and then you're done. Okay? 6 over 35 is the answer here. Find the multiplicative inverse of 5/11.
Oh, so like
What's the inverse?
multiplying the
11 over
It's
4.
Reciprocal.
11
Yep, 11/5. Find negative 2/3 plus negative 3/2. What is it going to be? Addition or subtraction? Addition. What's the final answer going to have? A negative number because these are both negative, and when I add 2 negatives, it becomes greater negative, right?
Yes.
So my answer is negative. So let's just forget the negative now. And how would we add 2/3 and 3/2?
Each one.
Is it division?
Yeah, it's fine. Right there.
Well, we're going to do addition first, and then we'll do division
Okay.
for practice. 2/3 plus 3/2 is 1.
No, actually that's not. I was canceling both.
We get a common denominator, right?
Yeah.
Or we can use the crisscross method that I showed you. Multiply these together,
Then multiply 2 times 2.
and then multiply 2 times 2, 3 times 3,
9.
and I get negative 13/6 if I were to add these.
So then you just leave it.
And I'm done because I can't, yeah, that's fine. All right, but this is division. Thank you for pointing that out. So when I divide by a fraction, I multiply by its reciprocal. What's a negative times a negative?
A positive.
And what's 2 times 2?
4.
Answer is 4/9. Positive. Okay, sum or difference. I think this is the last page, I hope. Okay, with these, I would recommend converting them to improper fractions. So I have 34/5 and 10/3. I can't simplify either. My common denominator is going to be 15. 3 times 34 is 102. And 5 times 10 is 50. So this becomes 152 over 15. And they want the answer as a mixed number. So I have to figure out how many times 15 goes into 152. Well, how many times does it go into 150? 10. And that's as close as I'm going to get to 152. Okay. 4/5 minus 3/4. I can still use the crisscross method here. It's a subtraction problem. Everybody agree?
Yes.
Okay. 20. 4 times 4, 16. 5 times 3, 15. Again, put this as 2 in proper fractions. It's a subtraction problem. This becomes 24. 8 times 17, I don't know. 136. 13 times 3,
36.
39.
39.
Yep, 136 minus 39 is 97. 24 goes into 97. How many times? 24, 48. 48 times 2 is 96. So it's going to go 4 times with 1 remainder, 1 over 24. I think that is the last question. Okay, so this should all be review from 7th grade. And also what we've been working on the first month of school, it feels like. Should be. Are some things that you were struggling with early, is it making sense now?
Yes.
Okay, so we're going to have a test over this material. It won't be this long tomorrow. And then we're going to jump back in on Wednesday and start section 4, which is the last section of chapter 1.
I can wear my PJs.
And then we take a chapter.
Yep, after that, we'll have a couple days of review.
Thank you.